actually, and we should be able to get rid of one bit of gibberish at the moment because it's flashing at random places now.
Flashing really, really fast.
But if I go to a different... Oh, I've got 4 now. I was just trying to get 2. Can I get 2? I just want to see if I can get...
Slow it down.
Whoa!
Got 1.
Oh, I was turning it up, that's why. Had the dial the wrong way around, sorry. Whoa, lots. That's too many. Okay. That's pretty much 1 now, isn't it? Are you videoing this?
Yeah. Wow.
Oh, you get my commentary as well, that's going to be exciting. I'll be a YouTube sensation before the end of it. 234 million hits, me and Gangnam style. So, that's quite nice, isn't it?
That's it.
But it's not good science because it's not synchronised anymore. We're seeing it at the top, then a bit lower down, 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 then at the bottom, then going up. So that's not synchronised properly. If I can synchronise it, we'll actually pretty much freeze it. Now what we're getting here actually, this is moving very slowly. What we're getting is kind of an illustration that the signal generator or the vibration generator, signal generator, vibration generator,
it's not bad.
but they're not doing it perfectly. They're not doing really even vibrations.
Stay still. And leave it. Yeah. It's kind of sort of faster.
Pretty much stationary there, but you can still see wiggles, can't you? Which means that something about this vibration isn't perfect. Have you done that, by the way?
Oh yeah.
Because that looks quite weird as well, doesn't it? It's why people dance like that in those sort of parties.
Yeah.
That and the fact they've been rotated actually. So, what we can do here is we notice that we've got which of the waves?
The overtone.
It's the first overtone, isn't it? Yeah. Can you see we've got a crest over here and a trough over there?
Yeah.
And this point in the middle called?
The node.
The point is called the node. And at that point we might say there's destructive interference, except of course that at this point we've definitely got constructive, haven't we? So I prefer to think of this whole string as doing something constructive because most of it is, it's just the nodes where things are cancelling out. Okay? Tell me some things I could do to change the pattern.
Increase the frequency.
Increase the frequency is the easy one.
Shorten the distance.
There we are.
So that's the secondary.
There's the second overtone. 1, 2, 3
So the wavelength
of the diamond shapes.
So the
wavelength is
half of this first.
no.
No, that's the first. That's the first.
The wavelength.
Don't change.
The wavelength. Oh, the wavelength's changed.
Oh yeah.
What's the wavelength here?
Gone shorter.
It's gone shorter. How would you actually measure it? Where would you measure from and to measure the wavelength?
So there to there.
From there to there.
No.
Bad luck. From there to there is one crest and then one trough. That's one complete wave, isn't it? But what the clever people would do, of course, is they measure the whole string because that's longer, and then you're going to be more accurate. If you're out by 1 millimetre in that much, it's a certain inaccuracy level. If you measure something longer and you're out by 1 millimetre, it becomes less, doesn't it? It's like if you're a millionaire and lose a pound, you're not that bothered. If you have £1.23 and you lose a pound, it's a bit annoying because that's almost all your money gone. So a change, like an inaccuracy, is important, but it's important compared to what you're actually measuring. If you're measuring the mass of the Earth and you're out by 2 grams, that's quite good. If you're measuring something to put in a chemical reaction in a science laboratory in a school and you're out by 2 grams, you could make a significantly different outcome to the experiment. So it depends what you're measuring. And here, if we measure something longer and we're out by 1 millimetre, say that's a whole metre, which it roughly is, a millimetre out of 1 whole metre is only a 1 in 1,000 error, isn't it? 1 millimetre out of 1,000. If we're measuring only up to there, we're out by 1 in maybe 600 or something like that. It's a worse error. Being out by 1 in 600 is worse than being out by 1 in 1,000, isn't it?
So you times the...
So it's like, you can work it out as percentages, in fact. We'll do this a bit more later. We call it inaccuracies rather than errors. It's how inaccurate you can be. And really, even if you're using a ruler quite carefully, because the metre markings, the millimetre markings are a millimetre apart, you can still be a bit out, can't you? And we have to realise at this level of science that even using good quality equipment, you could be a tiny bit out. If you know that, it means that you're going to be more ready to say to yourself, well look, I measured it was a millimetre, but I measured it was 100 millimetres, but I could be out by 1 millimetre, so my actual value is 1, I don't know, what did I just say, 100 millimetres, but I could be out by 1, so it could be 101, it could be 99. And every measurement you take could be a little bit out, and sometimes that has big effects. If you can think of something you've calculated where you've measured 3 or 4 things to do a calculation, if each of them was out by 1 or 2%, then overall it's going to make quite a big error between them, quite a big inaccuracy. And we'll do a bit more about that later. Back to this though. We've worked out this is called the second harmonic. We've got 2 nodes, we've got 3 antinodes, we've got a wavelength that goes from there to there, or from there to there, or we measure the whole thing and then find 2/3 of it because the wavelength's 2 of these and we've actually got 3 on the string. So measure the whole thing and find out 2/3 of that will give us that distance there. I can go on altering the frequency, can't I? Make it higher and higher. Should we do the 4th one just so you can see it? Ooh, I think I might have just missed it. It's a bit uneven, isn't it? Because we've got something weird going on here. I want to get a proper node going on there. I suppose the thing to do is to go down. Too slow. I'm trying to find where... Hey, doesn't it? I'm trying to find the fundamental frequency here. That's getting quite big, isn't it? And if that says that's on about 17, then the second one should be on 34. Ooh, I've gone past the second one. Now have I? Wait a minute.
That's the second.
Well, that's weird.
Maybe it's the dissonance. That's the third.
That was the third there, wasn't it? Yeah. There's the third. What's 3/17?
51.
51. It wasn't. It can't have been 17 because I've got 60 something there. Which, oh, that's the better one, isn't it? That's 3. Can we get 4?
It's 64. No.
It looks a bit like 4, but it's... Oh, that's not bad. We're not getting nice nodes there, are we? At the sort of quarter points along. And that's just going so fast we can't see it at all.
That's our little wave.
So, are there... Oh, there we are. Oh, it just gets there and disappears. Are there any other ways you can think of that I could make this...
Maybe move the light to the left. And
no, move
change
the light...
the wavelength.
Well, yes, how can I change the wavelength?
Wire, so make it shorter.
What do you mean? Change... Don't you... Wire?
No, the sort of pulse part. The distance.
That's quite nice,
The
isn't it?
longer distance to be able to easily get like full.
Oh, I see. So, stretch that back a bit. If I've got a longer piece of string to vibrate, my wavelength now, by making it longer, I fitted 3 on exactly before. Now I can fit 3 and a bit on,